9. Mirage maintenance. You ride the camel through the sandstorm and stop where the ghost map told you to stop. Alright, that was a funny day yesterday. I saw the subreddit and a lot of people were quite mad about yesterday's day because technically it shouldn't have been solved with LCM, but it could be solved with LCM. Anyways, the camel goes to get some water and stretches necks. As you look up, you discover what must be yet another giant floating island. This one made of metal. That must be where the parts to fix the sand machine come from. Okay, there's a hang glider, partially buried in the sand here. Once the sun rises and heats up the sand, you might be able to use the glider, and the hot air will get you to the metal island. While you wait the sun to rise, you admire the oasis hidden here. In the middle of the desert, it must have been a delicate ecosystem. You might as well take some ecological readings while you wait, because of course you will. Maybe you can report any environmental instabilities you find someone so that the oasis can be around for instabilities you find someone, blah blah blah. Yeah. You pull out your handy oasis and sand instability sensor and analyze your surroundings. The oasis produces a report of many values and how they change over time. That's the puzzle input. History of a single value, for example, numbers, more numbers. Okay, arithmetic sequence, not so arithmetic sequence, 2, 3, 4, yep, 3, 3, 5, okay, just some sort of fib, 6, and then 6 plus, yeah, this looks like Fibonacci on the last one. Okay. To best protect the oasis, your environmental report should include a prediction of the next value in each history. To do this, start by making a sequence from the difference at each step of your history. If the sequence is not all zeros, repeat this process using your C. So okay, check if it's an arithmetic sequence. If that sequence is not all zeros, yeah, repeat the process using the sequence used to generate the inputs. If that sequence is not all zeros, repeat this process using the sequence you just generated as the input for the sequence. Yeah, okay. Once all the values in the latest sequences of zeros, you can extrapolate. I guess it's telling me how to do the problem. It's interesting. Yep, arithmetic sequence. Note that the sequence has one fewer value than the input sequence because after each step, blah, blah, blah. The values differ by 0 each step. Okay, this means you have enough information to extrapolate. Yep. Start by adding. To extrapolate, start by adding a new 0 to the end of your list. Because the zeros represent differences between two values above them. This also means there's a new placeholder. A is 3. Okay, a lot of spoon feeding going on. And B is 18. Yep. Okay, so this one, is this a quadratic sequence? 3, 2. Yeah, I think this is an x squared sequence. X squared to. Yeah, some sort of x squared sequence. So the fifth value is 15. So 5 squared minus, yeah, some sort of x squared quadratic sequence there. This one here would be. I'm not sure what you are. Oh, you're also. Oh, this is the same one. Yeah, 28. The third history requires even more sequence, but the value can be found the same way. So the thing about this is that they then will be polynomial sequences always. I'm really tempted to make this a maths problem instead of the No, it's okay. Let's not make it. No, I think we should make it a maths problem actually. I think we should definitely make it a maths problem. But the thing is that this could go on for quite a while. Right, you could have x to the 8 sequences, and I don't really know the algorithm for doing that. I know like quadratic sequences, even cubics are probably fine. 3, 3, 3, 5, 5, 9. Yep. But then I bet my puzzle input is just huge. Well, you do this a lot of times. So I mean, they're not individually massive. So this isn't terrible. I'm going to start with a non-maths approach, and maybe we need to change it. That might be very wrong to do. But let's do recursion. Right, we take these, we find the differences. If the differences are not the same, we we go again. And again until it is zeros. Each time then finding the next thing. Filling the 2, and then filling the 8, filling this, and then eventually filling this. So it's kind of going to be a recursive solution. Okay. Recursion. Yeah, I think that will work. Yeah. Probably. But it is very much a maths problem about polynomials. But I'm going to do it this way because I have no idea what part 2 is, and this way is much more flexible in case we need to do something different with the differences. That is not purely polynomial. Okay, so what I'm going to do is I'm going to write some tests. Next num finder, and we're going to start with var nums, which is of type underscore usize. Yep. All right. And we're going to have a function next num, which is going to take. Does it need an allocator? We can probably do all this in stack allocations, maybe. So otherwise I might throw in an allocator in there. So what I'm going to do is I'm going to take nums, which is going to be an array of usize, and it is going to give a usize as the next number, and it doesn't need this. I keep forgetting. What we're going to do is we're going to do we're going to find the difference. Var diff is equal to an array of length nums dot length minus 1 of usize for 0 dot dot nums dot length n. I think it's length minus 1 actually, because we want to stretch. Var diff is equal to nums at n plus 1 take away nums at n. That will give me the diff, and we're going to say, just say d. Here we're going to say diff at n is equal to d. And basically we're going to ask if they are not all zeros, right? So, for example, we would do it once, 3, 3, 3, 3. They are not all zeros, therefore we go one more until they are. That's kind of the base case of our recursion. Function is all zeros. Nums, usize, bool, nums n, if n is not equal to 0, return false, otherwise return true. Cool. And that's exactly what we're going to do here. If it is 0, we're going to return 0. Yeah. If is all zeros, nums return 0. If not, we go through this, we find the difference, and we return the very last number, in this case like 3, plus the next number is going to be the last number plus the next bit. So imagine we are at 15. Yeah, I think that works actually. Yeah, return nums at nums.length -1 plus next num with the diff. Okay. Maybe we got that right. So I'm not actually too sure. Testing dot try expect nums next num of nums to be equal to 18. Zig test dot slash source then 9. There we go. Array literal requires address operators. Fair enough. So at, and you're going to return a pointer. You're going to use a pointer. You're going to use a pointer. That's fine. That's fine. Nums dot star, and then nums dot star, nums dot star, then nums dot star there. Expected type. Found 6. Pointer type child use size cast into pointer. Actually, yeah, good point. How do I just use this as if it's like a normal array? Do I do this, perhaps? Inferred array length. I mean, but then it's gonna do this thing, right? Where it's yeah. Oh, that's a good point. I mean, it is correct, but then there's another part here. Pointer child type child use size cannot cast into pointer type child array of use size. Is it brackets that it needs? No. I'm actually gonna see how to fix this. I'm not super sure. That's Rust. This is not really the thing, is it? Yeah, that's it should be able to just use it, right? Do I have to do like an underscore there? Enable to infer right size now. Zig function take button. Why couldn't I do this before? Why was that not allowed? Array literal requires address of operator to coerce to slice type. Yeah, this is the type of stuff I don't quite understand about Zig yet. Useless compile time for array literals and slice type. Okay, I think. Oh, right. Do I have to do? Yeah. Do I have to do that little gymnastic of like spreading the array out or something? I think I do. Let's go to you. What? diff. Wait, what? Oh. So I think I'm going to need an allocator here. Okay. Standard.heap.test allocator. Actually, just page allocator is fine. Allocator standard.heap.allocator standard.mem. I can't remember what the type actually is. Yeah, I understand this, I suppose. Let's just do it and then not free any memory, because very cool. Yeah, we need a try, so this becomes this. Try allocator dot alloc. We're going to allocate some usizes that are going to be nums.length -1. And we're going to give you the allocator. We can do an arena allocator, and then after this is done, we can just free, but... And then next num here, you're going to need allocator. We're going to need a try then. And we're going to need a try here. Okay. They all pass. Nums true. Now we need like the next test case, which is this. And this is 2, 3, 4, 5, 6. So we had 7, 28. Okay. And just to be sure, let's take you and do this. And it should not be 28, it should be, I'll be able to figure it out for myself. 68. Okay, good. So next value, so if you find the next value for each history in the example, add them together. Okay. So we're going to take each one. We're going to put them into an array. Yeah, I never know the best way to do this. I'm just going to use an array list and be very inefficient there, but whatever. It's fine. It's fine. It's fine. Part 1, use size is 0. So for input line, var allocator is equal standard.heap.page allocator. We're going to do var list equals standard dot array list of type usize dot init for the allocator, and we're going to free it at the end. We're going to do list.deinit like right there, and for each line what we're going to do is var tokenizer equals standard.mem.tokenize sequence. We're going to tokenize a U8 from the line of the space while tokenizer.next n try list.append try standard.format.parseInt view size, the int is n, going to be base 10 deinit, and here what we're going to do is we're going to say var next num. Hold on, just one sec. Right, let's continue. Var next num is equal to next nums. Actually, I'm gonna pull that in. Next num. Just gonna take an allocator. Take that one, and let's just leak memory. I just leak the memory. List of items. And then part 1 plus or equal to n. Okay, list d in it. Yeah, leaky memory. It's fine. It's all good. Const print equals standard dot debug dot print. Print part 1. Part 1. One for 4. And integer overflow. Oh, they can be negative, of course. Yeah, they can be negative. So they can't just be use sizes, they have to be let's go 128, be really overkill. It's all good. I 128. Okay. Alright, that was straightforward. Of course, it would be nice to have even more history, including in your report. Surely it's safe to just extrapolate backwards as well, right? For each history, repeat the process of finding differences until the sequence of differences is entirely 0, and then go backwards. This is fine. Adding the new values on the left side of each sequence from the bottom to the top eventually reveals the new leftmost history value. Best way to do this is to flip these. You reverse the numbers, right? So from top you get a 5, a -3, 0. You just reverse, right? Like you don't even bother doing anything hard, you just reverse. You go and 1 and 1. There we go. We say list.items dot standard dot none dot reverse. I128 list dot items, and then bar n2 equals try next num allocator list dot items part 2 and 2. That looks really low. Wow, what a day! That was easy, guys. This is like the fastest one of the whole thing. I think I found number 1 maybe slightly harder. Wow, really cool. I'm glad that was it. I can get on with my day. Awesome. Thank you so much for watching, and I'll see you tomorrow.